Get ready to learn Python in 25 minutes. If you want a detailed Python tutorial, make sure to go down to the description and press the link that will take you to my Python tutorial playlist. Now, let's start. Head over to this website, www.python.org, go to download, select your OS, and then hit on latest Python 3 release. Once Python is installed on your machine, press on the Windows key and type Python to make sure that Python is actually on your machine. Next, we need to download an IDE, which is a text editor that allows us to write, run, and debug code. There is PyCharm, VS Code, and Atom. You can download one of them. Link will be in the description for the three of them. To understand variables, here's a metaphor. A variable is like a box that stores different items, like a ball, let's say, some books, some pillows, and so on. And because there is three boxes, we will name each one of them box 1, box 2, box 3. So variables have names that should be descriptive and understandable. To declare a variable in Python, all you need to do is just write its name. I'll say box 1. And then add the equal sign because we need to assign data to the variable by using this equal to sign. In Python, variables stores different type of data. First, I'll explain the Boolean. Boolean values can only be true or false. If I say is connected equal to true, that means the user is connected. If not, it will be equal to false. Those are the Boolean value. They can only be true or false. Next, we have strings, and strings are just plain text. If I want to say hello world in Python, I'll let's say store it in a variable called greet and open double quotes because strings are referenced with double quotes. Inside, I will write something like hello world. Using the print function, I could actually print something to the console, and then I'll mention the variable name. And here you go, we have hello world. So whatever comes inside double quotes are called strings. In programming, we have the concept of indexes, which represents the position of a character. If I say print greet brackets 0, in programming, indexes start at number 0. So this one is element at position 0, this one is element at position 1. So if I say greet index 0, I will get H. If I say -1, I'll get D. So when you have negative values, it will start backwards. If I say something like 0, 3, I shall get HEL. That means start from index 0 all the way to index 2, because always the last value is excluded. It means like saying 3 minus 1. That's why we got the element at index 2. If I say something like 3, it will print me the same thing, because it is just like saying start from the first index, which is 0, all the way to index 2, because the last value here is excluded. Same if I say 1 and don't mention the ending, I will get the element from index 1, which is E, all the way to the end. And if I don't mention anything, it will print for me the string, because that means start from the first index all the way to the end. We could also use some functions that are inbuilt in Python to modify our string. If I say print greet.upper, it will turn all the letters to uppercase. If I say greet.lower, it will turn the letters to lowercase. As you can see over here. If I say something like greet.title, it will turn only the first letter of each word to uppercase, as you can see over here. And if I say greet.find and mention what I want to find in my string, let's say the letter E, it will return for me the index of that letter. In my case, it is at index 1. I could also use the plus sign to concatenate two strings. That means join them together. I have the hello variable and world variable. I want to link those strings together. I'll say something like print hello, the name of the variable, plus white space plus world. Those empty double quotes are just spaces to separate those two words. And this is called string concatenation, where you concatenate or join two strings. I could store this output inside a variable. So if I say x, let's say, and let me take off the parentheses, I could print right now x. It will give me the same output. Next, we can store numbers. Numbers can be integers like 1, -1, and so on. So I could say 1 over here, or 12, let's say. Num2 could be, let's say, -12. They can also be decimal numbers, also called in Python float. So I could say in des1, I could say 2.3, or in des2, I could say 45.6. We could perform arithmetic operations with those numbers. If I say print num1 plus num2, it will give me the answer. So I'll get 0. Definitely 12 minus 12 is 0. But if I take off the minus, I should get 24. I could also subtract two numbers by mentioning the hyphen or the minus sign, and definitely I'll get 0 right now. I could multiply them by using the asterisk sign, and I'll get 144. I could divide them, and I'll get 1. I'll get a floating point number, because using this division sign, it will give us a floating point number. But if I say double front slash, I'll get 1, because this division is called the floor division, which will round the number to the closest integer. We also have the modulus sign, so if I say 10 mod, it is represented by the percent sign 3, I should get 1. And what this means is it will return the remainder of a division. 10 divided by 2 has the remainder of 0, but 10 divided by 3 has the remainder of 1. So we got this answer. We have something called the augmented assignment operator. If I had x equal to 12, and I want to increment x by 1, and then store the answer inside x, I could say x equal x plus 1, and then I could print x. I'll get 13. But I could write this in a much simpler way. I could say x plus equal to 1, and then I'll delete this one because it is the same thing, but this one is much shorter. So again, I will get 13. This is called the augmented assignment operator. Make sure to try them out with other operators than the plus sign. You could do this with the minus, the multiplication sign, and the division sign. We could also compare two numbers, and this thing is called a comment. It is not read by Python, and it will not be executed. So the comparison operators are the greater than sign, less than sign, greater than or equal to, less than or equal to, the equality sign which tests the equality between two numbers, and the difference sign. We'll see them right away. So if I say something like print x greater than y, x is 12 and y is 13. So definitely we should get false because x is not greater than y. It will return for me a boolean value of false because x is less than 13. So if I say less than, I'll get true. But if I said 10 greater than or equal to 10, I'll get true because 10 is actually equal to 10. But if I say 9 is less than or equal to 10, it is true because 9 is less than 10. Now the double equal sign, that's the equality between two numbers. If I say 12 equal to 12, is 12 the same as 12? Of course it is. So that's why I'll get true. But if I say 32, is 12 the same as 32? No. So I'll get false. Don't mistake this comparison operator to the equal or the assignment operator. This operator assigns data to a variable, while this one compares to numbers. But if I say something like different, definitely they are different, so I'll get true. Next we have the logical operators. They can be and I will write them down for you, and, or, and not. We'll see them right away. So when I say something like print x less than y and x less than, let's say, 9, it will give me false. Why exactly? First it will test the first condition. Is x less than y? Yes it is, so we'll get for this true. And then it will go to the next operation. It will say is x less than 9? 12 is less than 9? False, so we got false for this condition. And because we have the AND operator, both conditions should be true in order to this full expression to evaluate true on the console. Because we have only one condition that evaluated false, that's why we got false. But if I say instead of AND I say OR, I should get true. Because with OR, only one condition should evaluate true in order to get true in the console. Because this condition evaluated true and this one evaluated false, and we have the OR operator, so we got true in our console. But if I say something like not will actually negate your expression. So if x is less than y, yes, we'll get true. But because you put the not operator, you'll get false. So remember, when the expression is true and you have not, it will become false. And vice versa, if the expression is false, it will become true while using the not operator. Next we have the identity operator. If I say something like print type, and type will find the type of the data stored inside a variable of x, and then I'll say is, and is the identity operator, int. Int means integer. So in my case, I should get true because the type of x is actually an integer. But if I say something like float, I should get false because it is not a floating point number or a decimal number. Also, if I say str, which means string, I'll definitely get also false because it's not a string. And if I say something like bool, which stands for boolean, it is not a boolean value. But if I say something here, type of true is bool, of course I'll get true. We also have the membership operator. I could say something like h in, and in is the membership operator, in x. So this will return for me a boolean value if h is inside x. So in my case, I'll get true because it is inside x. But if I give something like z, and z is not actually inside my string, so I'll get false. I could also say hel, and I'll definitely get true because it is actually inside my string. Variables can also store lists, and a list is referenced with brackets. And inside brackets, you could put any data type. I could put also a list that contains other data inside. Let's say A and B. So it contains two strings, and we have a list inside of a list, which is right over here. We could use indexes to fetch individual elements. I could say print lst index 0, which will give me the first element. Let me run my program, and we got 12. I could say also 1, and we will get hello. But if I say -1, I'll get a list, because this list is actually at the last index. But if I want to access A, how could I do that? So I said over here lst index -1, which gave me the list. If I say another index and mention, let's say 0, I'll get this time A, because first it will go to the list, which is at index -1 or at the last index. Then it will search inside that list for the element at index 0, which is A. You could also say 0, 2, which will start from element at index 0 to element at index 1. So I'll get 12 and hello. I could also say colon 2, and it will print for me the same thing because it will start from index 0 to index 1. I could say something like 1 all the way to the end, and it will print for me, as you can see in front of you right now. Just like how we use functions inside of string, we can do the same thing here in list. I could say lst.append, and append will actually add an element inside of my list. I could say 13, I will add a number, and then I'll print lst. As you can see, it will add the element at the last index. I could then say lst.remove, and it will remove the element that I'll mention inside parentheses. I remove 13, and as you can see, it removed 13. I could say lst.insert, and inside the parentheses, I could mention the index that I want to insert number 13 at. So I'll say at index 2, I want to insert number 13. And let us see what will happen. I'll get number 13 at index number 2. Next, we have the pop function. So if I say lst.pop, and inside I want to mention the index of my element that I want to pop, I'll say at index 0, I want to pop number 12. And with the pop function, I could actually store the element that I pop in a variable, which I'll call it x. Then I'll print x and the list. So we got 12, and 12 was removed from the list, but was stored inside of a variable. So the pop function allows you to remove a certain element inside of a list and store it inside a variable. The remove function doesn't allow you that, it will remove it completely. We also have lst.clear, which will clear or remove all the elements inside of my list. As you can see, I have right now an empty list. Next we have lst.count, and inside count I want to mention the element that I want to count the number of occurrence of this element. If I say 12, and I'll add 12 here 2 times, or 3 times let's say, and I could store the output of this function inside of a variable, and instead of printing list, I'll print x. It gave me 3, and 12 appeared 3 times inside my list. So the count function actually counts the number of occurrence of your element. We also have index, and we'll find the index of the element that you'll mention inside parentheses. If I say hello, it will find for me the index of this element. So it is at index number 3. Next we have tuples, and tuples are actually immutable. They are not like lists where you can modify them and change the elements inside of them. When you assign to a variable a tuple, you cannot anymore remove or add something new to the tuple. And tuples are referenced with parentheses. Inside parentheses, I could mention any data I want. Now we could use indexing to actually fetch individual elements. I will say x equal tup1 index 0. And this will fetch for me the element at index 0 and store it inside x. Right now I could say print x. As you can see, we got 12. I could also modify this number by adding 2 on it, and I'll get 14. If I say 3 and print x, look what we will get. We should get true. If I say 1, 3, I should get 34 and hello. But this time they will be stored as a tuple inside of my variable called x. Now using tuples, we only have two functions to actually work with tuples. So if I say x equal to tup1 dot count, and we actually saw this function inside list, and I will count the number of occurrence of number 12, and then I'll print x, and number 12 appeared only one time inside of my tuple. Also, we have the index function, which will find the index of my element. So I'll find the index of number 12, and it is at index 0. We can also store sets, and sets are referenced in curly brackets. And this is a set in front of you right now. It is a set of numbers. And if I print this set, as you can see, we'll get the set that has 1, 2, 3, 4, 5. Remember, in sets, you don't have indexes. So I cannot say index or set 1 index 0. And I'll get the error because there's no indexes in sets. But we could use functions. So if I say something like set1.add, it will add for me an element. I will add number 6. Let me print my set. I'll get 1, 2, 3, 4, 5, and 6 because I added 6. If I say set2.remove number 6, it will remove for me number 6. Oh, excuse me, there's no set2, there's set1. And number 6 is not anymore inside of my set because I removed it. Those are very basic functions used in set, but sets shine in the mathematical operations that they can perform. Let me show you one function. So if I say set1.intersection set2, it will find the common elements inside of those two sets. We have 1, 2, 3, and yes, that's correct because we have 1, 2, 3 in both sets. Check out this video in my Python playlist to learn more about sets. Next, we can store dictionaries, and dictionaries are a bit different from the others. Dictionaries have keys and values for different keys. So number 1 is the key, which stores the value Paul. Number 2 is also a key that stores the value David. So if I say print deco, and inside brackets I won't mention index numbers because there's actually no indexes in dictionaries. What I'll mention is the key. I will mention key number 2. We'll get David. So we'll get the value of the key, which is number 2, and it has the value of David. I could also add a new element inside of my dictionary. I could say deco and open brackets and mention the key name. So I'll say 3 equal to, let's say, John. As you can see, we added a new element, which is John. We could also use functions on dictionaries. If I say deco.update and I say something like, of course, open curly braces and mention first the key, which is 4, and I'll add, let's say, Kelly. And we got Kelly at the end. I could also use a function that will store the keys of this dictionary inside of a variable. I'll say x equal to deco.keys. And before printing x, I need to convert this function into a list. By mentioning the list function, I will convert this function into a list. Right now I could print x, and here we go. We have the elements or the keys of the dictionary inside of a list. Check out this video about type conversion. I could also store the values of the dictionary inside of a list. So I could do the same thing, list deco.values, and the values function will actually fetch for me all the values inside of this dictionary. And let's print x and y. X, print y. As you can see, this is the list that stores the keys. This is the list that stores the values of this dictionary. We could also store the items of this dictionary inside of a list. I could say z equal to list deco.items. As you can see, it stores the items of the dictionary inside of a list. But we have the key and its value inside of a tuple. Sometimes in our application, we want the user to input data. So we could use the input function and make the user input their name. But because their name should be a string, I need to convert this input to a string by using the str function. And right now I could print like hello x. Now it will ask me for a prompt. I'll say textsend and it will say hello textsend. Now there's no space in here, so I'll space it out a bit here and let me say textsend hello textsend. I could also input a number, so I'll say input number. But instead of converting this input to a string, I'll convert it to an integer because I need this input as an integer. Now if I print x, as you can see, it will ask for me to input a number. I'll say 12, and we got 12. I could also input a floating point number by saying float, and I'll say something like 12.2. And we got 12.2. But let's say I inputted a string instead of a float. Look what will happen. We'll get an error because we said that we want to input a float, but instead we got a string. And that will crash our program. But to prevent crashes in our program, we could actually use try and except block. So I could say to Python try, and after try comes a block of code that Python will test. So when you say try, you're telling Python, please try the block of code that will come after this colon. And inside this try block, it will actually try this expression. But let's say Python finds an error. Instead of crashing the program, I'll say to Python, I'll accept this exception, and I'll give this exception a nickname by using the as keyword, and I'll say e. Now if I say print e, and then I'll print something to the user to tell them that I want them to input a floating point number. Now if I launch my program and I'll input a string, instead of crashing the program, I actually return to the user or explain to the user that they should actually input a floating point number. But if I input a number 12.2, nothing will happen. It will print for me x. Next we have if and else. We use if and else to make our program more logical. Let's say I want to compare two numbers, num1 which is 12 and num2 which is 13. I could say if num1 greater than num2, I want to print num1 is greater. So if this condition evaluates true, it will print for me this print function. But if it didn't evaluate it true, it will go to the next condition. I'll say elif, and elif stands for else if num1 is less than num2. I'll say something like, so if this condition evaluates false, it will jump to the next condition. If this condition evaluates true, it will print this expression. But if this condition also evaluated false, it will jump to the else block, and else means otherwise. If all of the expressions or all the conditions above evaluated false, print this block of code. So I'll say equal. The numbers are equal. So let's see. We got 13 is greater. So is num1, which is 12, greater than num2, which is 13? False. So this condition evaluates false. We'll jump to the next condition. Elif num1 less than num2, yes, 12 is less than 13, will print 13 is greater. And it will stop over here, and it will not print for me what's inside the else block. Next we have loops. Let's start with the while loop. And the while loop should have a condition and a counter. I'll explain that right now. I'll say counter equal to 1. I'll say while counter is less than or equal to 10. I'm gonna print round counter. And I'll say counter plus equal to 1. I'll explain that later. Let's see what's the output. So we got round 1, round 2, round 3, round 4, all the way to round 10. First, with while loops, you will always use a counter. Next, the while loop will take a condition, and as long as this condition is true, it will execute the block of code that comes after. It will print for me round, and then print the value of counter, which is right now 1. Then if I don't increment my counter by 1, I'll get an infinite loop, and it will never end because counter will always be less than 10. So that's why I'll increment my counter whenever I finish this print function. And then when counter becomes greater than 10, it will stop the program because this condition is no longer true. If I want to do it in a reverse way, I could say over here 10, and I could say while counter is greater than or equal to 1, I will print round and counter. But instead of incrementing by 1, I want to decrement by 1, which means subtract by 1. So I'll get round 10, 9, 8 all the way to round 1. Next we have the for loop, and the for loop is actually very different from the while loop. It doesn't take any condition. And the for loop is actually used to iterate over a sequence, like a list. So if I have this list that contains the number from 1 to 5, let's say, I will iterate through this list by using the for loop. So for I in LST, I will print I. Look what will happen. I got 1, 2, 3, 4, 5, which are the elements of this list. So first I will go inside this list. I will be first 1, it will print 1, then I will become 2, it will print 2, all the way to 5, and then it will stop. I could create a new list, which is an empty list, and inside of it I want to store the elements of LST number 1, but doubled. I'll say lst2.append, we saw this function actually, and I'll say I multiplied by 2. And when I say outside the for loop print lst2, as you can see, we have the elements of LST number 1, but doubled by 2. So 2 multiplied by 1 is 2, 2 multiplied by 2 is 4, and so on. So this is the for loop, but we could also say something like for I in range 1 to 11. And what the range function will do is it will create a range of numbers from 1 to 10 because the last element is always excluded. I could print right now, print round I. And I forgot to actually say for I in range. And look what we'll do. Round 1, 2, 3, 4, 5 all the way to 10. I could also mention another parameter which is the step. And let's say I set 2 over here. Watch what we'll do. It will print for me round 1, 3, 5, 7, and 9. What it did first, it prints I, which is equal to 1, then it adds 2 to it, and it will become 3, then 5, then 7, and so on. So it is called the step. Also, I could print the range of numbers in a reverse way. I could start from 10 and finish it up with 1. I said 0 because 0 is excluded, and of course I need to mention the step, which is minus 1. So I got round 10, 9 all the way to 1. Alright, this is it for today's video. For a detailed Python tutorial, go and check out this playlist. Anyways, I hope you enjoyed this video. This is Texent, and I'll see you guys in the next one.